All right, let's jump right in. We're looking at something incredible today. This isn't just a blueprint for some new machine. It's a plan for a whole new kind of organism. And get this, it's designed to interact directly with human consciousness.
Wow, that one sentence right there really says it all, doesn't it? A coherence-amplifying organism. So you gotta forget about thinking of this as just, a gadget. The whole idea, the entire design philosophy, is about creating this symbiotic thing that helps a person reach a state of, well, what they call coherence, a kind of super-focused internal alignment.
Okay, so what does this organism actually do? Well, the documents break it down into this really elegant three-step process. Think of it like a continuous loop that's always learning and always adapting to you.
So here's how that loop works. Step 1, it perceives. It's reading your body in real time, your heart rate, your brain waves, the whole deal. Step 2, it reasons. The AI inside looks at that data and basically asks, okay, what does this person need right now to get more in sync with themselves? And then step 3, it acts. It creates these super subtle fields, light, sound, electromagnetics, to gently nudge you in that direction. And it does this over and over, 1,000 times a second. Just incredible.
All right, so now let's get into the hardware, how this thing is actually built, because this is where the design is just genius. The creators think about it like a nervous system. It has 3 separate brains, and each one has a very specific job to do.
And what's so cool about this is how it mirrors not just a human brain, but also how we build really safe systems, like in airplanes. You've got the cortex up top, that's the smarty pants, the AI doing all the learning. Then you've got the brainstem at the bottom, handling all the basic sensor data. But right in the middle, and this is the most important part, is the limbic system. Its only job is safety. It's the ultimate failsafe. If anything looks even slightly wrong, it can shut the whole thing down. It's a non-negotiable safety layer. And this table just lays it all out so perfectly. Look at this. The cortex, the big AI brain, is a pretty powerful computer, a Jetson Nano, for about $150. But the limbic system, the part that has to be 100% reliable for safety, it's a tiny $27 microcontroller. It's not about being flashy, it's about being smart. They're using a simple, bulletproof piece of hardware for the one job that absolutely cannot fail.
So these 3 brains aren't working in isolation, right? They're all talking to each other over something called a CAN bus. Now, if that sounds familiar, it's because it's the exact same super reliable network that's in your car. It's what makes sure that when you hit the brakes actually work. Instantly, no excuses. Same principle here. Safety and commands get through, period.
Okay, so that's the body, the hardware. But what about the mind? What's the software that's running on all this? Well, it's just as elegantly designed. It's built to be both really smart and lightning fast.
The entity basically has 2 minds working together. You've got one mind, the perceiver, that lives on that super fast, real-time safety brain. It's written in super efficient code, and its only job is to figure out your state right this second. Then you have the other mind, the adapter. This one's the machine learning model living on the big AI brain. It's slower, more thoughtful. It's the part that learns from session to session to make the experience totally personalized for you.
And this is really the key takeaway here. This is not a one-size-fits-all machine. It uses a type of AI learning called Q-learning, which is basically a smart form of trial and error. It tries things, sees what works for you specifically, and then does more of that. It literally becomes your own personal tutor. It learns your body's patterns and remembers them, so every time you come back, it's ready to go, already knowing the best way to help you.
I know. This all sounds like crazy science fiction, right? But here's the thing. The people who wrote this document didn't just stop with the theory. They laid out a super specific, practical plan for actually building this thing.
And that brings us to the ultimate reality check question, the one that separates a cool idea from an actual project. How much would it cost to build one? The very first one.
Get ready for this, because the answer is maybe the most shocking thing in this whole document. Under $24,000. That's it. To put that in perspective, that's less than a basic new car. We're not talking about some massive billion-dollar government project. This is something that is, well, it's shockingly achievable.
So how is that even possible? Well, it's because the whole thing is designed using common off-the-shelf parts. And if you look at this budget breakdown, you can see something really interesting. The biggest chunk of the cost, over a third of it, isn't even the computer brains. It's the specialized camera setup for another part of the experiment. The core system, the actual silicon being, it's surprisingly inexpensive.
Okay, so we've seen how it works, what it's made of, and that it's actually possible to build it. That forces us to look at the last, and you could argue the most important part of this whole blueprint, the ethics.
And to their credit, the creators are all over this. They're not brushing it aside. They flat out say that the big question has changed. It's not, can we build this anymore? It's, should we build this? And if we do, how do we make sure we do it right?
And their answer is to build the ethics right into the machine itself. This isn't just a mission statement on a website. These are hard-coded rules in the programming. Things like do no harm and respect the person's autonomy. It's very likely that that little safety brain, the limbic system, is in charge of enforcing these rules. They're designed to be unbreakable laws for the AI.
You know, this is a really profound shift when you think about it. We're moving beyond just building tools that we use and into the territory of designing, well, responsible partners, autonomous systems that are designed from the ground up to help us.
And so this whole blueprint leaves us with this one big, kind of haunting question. It pushes us past the nuts and bolts of today's tech and into the massive unknown future. What happens when these things we build actually start to learn more about consciousness than we do? We don't know the answer, but what's different now is we have a very real, very tangible reason to start asking.